Hi everyone. My name is Brinke. I'm very excited to be here. Also, a warm welcome to people maybe watching online or watching it later. This includes my fiancée Melanie, who I'm getting married to in a few weeks. So, hey Melanie, I love you. And thank you very much. Thank you very much. Today we're not here to talk about my fiancée, though I could do that for an hour. We're going to talk about something else. We're going to talk about .NET configuration and secret management. And you could wonder why. Why do I talk about this? Like, you guys probably know what a connection string is to a database. You probably know what configuration kind of means. Why am I here talking about this? Well, .NET configuration system is very powerful, but it's also very flexible. Meaning that I've been at several companies, several kind of areas, and every company does configuration and secret management a different way. Some do it the way that Microsoft kind of, wants you to do it, and that's fine. Some do it in a way that completely goes against what Microsoft wants you to do, which then kind of results in really difficult code. And then also there's a lot of insecure ways, right? That's kind of the secret management part, which we're also going to talk about today. So I want to teach you everything that you need to know about configuration management and secret management in .NET. A little bit of a story to start with, right? We're now right here, NDC Copenhagen, really cool to be here. I'm from the Netherlands, and the Netherlands and Denmark share a lot of similarities, right? We both have a lot of bikes, and we love biking, we love cycling. We're great buddies that way. The Netherlands, also have stroopwafels, and I brought those as well. So if you want some Dutch cookies after the session, come to me. There's also one at the green card box. And finally, we also have a shared love for licorice, and I've been told I need to pronounce this as lakritspipe. Oh, there you go, there you go. So how does this relate to .NET configuration and secret management? Well, in the Netherlands, we also have the Dutch tax administration. And that sounds boring, but it's actually a story related to everything we're going to talk about today. In 2021, there was a Dutch white hat hacker, and he was looking around at the GitHub profile of one of the Dutch tax administration IT employees. And in there, he found a repo that had his personal access token to the private GitLab account of that employee. So, he clones that, he takes a look in those private GitLab accounts, a couple of some fun projects and all that kind of stuff, and a repo that contained a text file with all kinds of usernames and passwords for Dutch tax administration cloud services. So, of course, he's already writing an email to the Dutch tax administration security services like, hey, what is going on? When he notices global Azure admin login. So, of course, you go to portal.azure.com. You fill in the username, you fill in the password, and they were correct. So, luckily, we have a very secure country, right? We do things in a secure way. We had MFA enabled, but this was 2021, where the only MFA prompt on your phone was, are you trying to log in? Yes and no. Of course, he presses yes. That person pressed yes in 5 seconds, and this guy now had global Azure admin account access to the Dutch tax administration. This story had a happy ending. He got a trophy sent home that said, I hacked the Dutch tax administration and I never got a refund. And this is funny, right? This is funny. But then you think, and also why I talk about this topic so often, this is not difficult. Don't put them in your repo. This is not difficult, guys. What are we doing? But if this is the Dutch tax administration, what other companies are making these kind of mistakes? Let's talk about it. Samsung, March 22. Thousands of secret keys were found in leaked Samsung source code. Some repo got leaked, all of their secrets were just plain stored in Git, and there you go, lots of leaks. January 24, Mercedes-Benz source code was leaked because somewhere a GitHub token was found, and then someone cloned all the repos. I think this was for the Mercedes-Benz dashboard in the car and stuff like that. And next, this Rabbit R1. Who knows what the Rabbit R1 is? Who's heard of it before in the last few years? Yeah, okay, around 10 people, something like that. So this was a little device that you could clip onto your shirt, and it would be like an AI assistant. It would replace your phone. Mind you, this is 2024. We didn't have like Opus 4.8 and stuff yet. But this was a colossal failure, performance-wise and how it worked and everything, and also security-wise. On the device, some researchers found all kinds of API keys to the services. They stored those on the device. And with those keys, like Azure keys and Twilio and all these kind of cloud services, In the end, the security researchers would have been able to brick all devices on the planet by abusing the keys stored on every single device. This happens all the time, and it's not going to stop. In fact, it gets worse. GitGuardian, a company for Git security and Git management and stuff like that, every year publishes a really interesting report called The State of Secret Sprawl. Now, I took a look at what they said this year, and let's go through this to really drive the point home that this is something that as an industry we have not solved yet, and it is really up to us to fix this. In 2025, 28.5 million new secrets were detected in public GitHub commits. Now we have coding agents. Claude Code co-authored commits leak secrets at 2 times the baseline rate compared to humans. And we're all using coding agents. Everything is coding agents. Luckily, this has been improved with the new Opus and Sonnet models. The rate at which AI coding agents leak secrets is now at the same line as humans do, which is still way too often, but at least it's similar to us. Then you take a look at how this is going over the years, right? Not just this year, but how this is developing. AI coding agents and just AI in general, you can see that there's loads of extra developers coming onto the scene, way faster than before. Like you can see in 2021 and 22, there were 3 million secrets leaked, and in between 2024 and 2025, there were 8 million more secrets leaked that year. And this is not going to stop. The more developers, the more this is going to happen. This means that there's 152% leaked secret growth since 2021. There's been 1.2 million AI service secrets exposed, so that's going to be a really expensive bill. And finally, 15% of commit authors have leaked a secret in their career. So before we really get started, I want to ask you one simple thing. Have you ever leaked a secret? I want to see around more than 15% in this. Yeah, that's kind of 15%. That kind of works. Proud of you. Keep it up, right? And this is not going to stop. This is not because we don't understand how .NET's configuration system works. A little bit, perhaps. We're going to talk about that. But also because it is easy to do. And we as an industry have not really implemented the policies to work around this and to fix these issues. And today we're going to talk about a broad aspect of that. My name is Brinke. I'm a senior software engineer and knowledge officer at Arcadie. I do a lot of .NET consulting, app development, cloud, DevOps, front-end. I always say I do everything except for CSS, because I don't know CSS. I cannot do it. I'm an MVP. I love blogging, speaking, podcasting. I do a lot of open source around ASP.NET Core nowadays. And I just love speaking and being here with the community. You can see a QR code here, the blog post of my session. You're going to see this a few more times throughout the presentation, also at the end. So don't worry about it if you cannot scan it now. But for every session I give, I always write a blog post. So if you want to share the text version of this session with your colleagues, or you want to go through it again tomorrow, just have a look at that. And of course, you can watch this back on YouTube. OK, so we have around 50 minutes left. And in those 50 minutes, we're going to cover the following things. We're going to talk about the basics of configuration. Then we're going to talk about the options pattern and why you should kind of stop using the basics of configuration in your code and why that could be considered harmful. We're going to deal with development, and then we're going to push to production and see how we should manage configuration and secret management in production. I always like to say that I want you to feel free and interrupt and ask questions. We're going to have a lot of content to go through. Maybe we have to skip a few demos if we have lots of questions, but I prefer that. I prefer having a lot of interaction instead of me just sending 50 minutes, 60 minutes to you and then you leaving. So if you have any questions, or if you're like, no, you're wrong, or hey, this is no longer correct, or whatever, any stories to tell with other people, please do so. So the basics of configuration in .NET. Let's talk about what configuration actually is, so we have a baseline, and why it is important, right? So configuration. Easily said, I always say that it's kind of the settings screen of your application. It's not the business logic, but it's kind of the stuff around it. It's, for example, your feature flags. Is this new feature enabled or not? It's your connection strings, it's your logging settings, stuff like that. Makes sense. A lot of, I think basically all us developers are using stuff like this. And it's important because if we would not have like kind of a settings screen or like things we can plug in and change at the application, and we would have to bake that into the code, we're going to probably get like, if development is environment, then the connection string of the secret is this, else, else, else. Or you're going to create a different build for each environment with the secrets baked into it, which is super insecure. Configuration allows you to plug that in like after or during your deployment and stuff like that. So in .NET, how does this work? Basically, there is an interface called iConfiguration, and this has providers behind it. As a developer, you don't know what providers you're using or what provider is providing you a value, but this list is long and can be changed by you as well. So you have your app settings.json, app settings.development.json, environment variables, command line arguments, and other sources. There's also TOML, XML, INI, loads of different kind of providers. You can also build your own. There's cloud providers available to you as well, which we're also going to talk about. And this is really, really interesting. It's basically the new, it's like 10 years old, right? Since .NET Core. iConfiguration is that system. In code, that looks like this. Somewhere we have a property iConfiguration, and maybe we want to get the API key. So what you can say is you can say configuration get value, and you provide the generic type of the value you're getting, like a string, int, boolean, whatever. And you can say API key, and this returns a string. And this now you have the API key from the system, or you can use an indexer, which always returns a string. Simple enough, probably very similar to how you deal with configuration in other languages, other frameworks. And then there's structure, and this, I believe, is where .NET really differs from how other languages solve configuration for you. So I think, who is familiar or who is not familiar with app settings.json here? One person, that's completely fine. That's completely fine. Here, you are. Okay, that's right. Well, there you go. Everyone is then. So app settings.json, right? Log settings, allowed host, connection strings, features, and these are not just key values, these are structured JSON objects, right? So to explain a little bit more about iConfiguration and the APIs available to you, you don't just have iConfiguration, you also have iConfiguration section. So you can say, from this entire configuration system, give me the features section. Or you can say get required section, which will return an exception if that section does not exist. I prefer to always use get required section because your configuration system doesn't change structure-wise at runtime, I hope. So I prefer getting an actual error when it doesn't exist. I will also tell you that you shouldn't really be using this in production code in your business logic. You should be using the options pattern. We'll also talk about that later. But now you can basically get a small part of configuration. You could also say, no, I just want to drill down into my configuration system. You can say features, features, enable new UI. And you drill deeper into the system, is what I'm trying to say. Okay. One thing that I often see developers not realize is that every provider supports structure. It's very easy to see how JSON does that because it's an object. But for example, in environment variables, or when you pass them through the CLI, you can do 2 underscores, a feature, underscore, underscore, use feature. And the Azure Key Vault, who is using the Azure Key Vault here for production? Yeah, loads of people, right? There you need to do it by 2 dashes because they don't support underscores in their names. But this is how you can use that structure, which I think is useful because otherwise you get such a file with loads of little bits of data and strings and stuff, and it's difficult to see what belongs together. It's nice that you in .NET can structure this. So how does this work, right? Well, what you need to do is you create a configuration builder, you add providers to it, you call builder.build, and then you end up with an iConfiguration root. This is basically the same as iConfiguration, but it has a list of all the providers. You shouldn't really be using iConfiguration root. It's not added to the dependency injection container at all anyway. And this is how you do that in code, right? So we could say add environment variables, add JSON file, and call build. But then there's the question of, well, what if both of those providers have a value for a key? Let's call it API key, for example. How does that work? This is another thing that I don't see a lot of developers knowing, which leads to confusion and weird code around configuration usage. So what happens is that it is based on the precedence on how you add it to providers. So if you first add shared settings.json, then app settings, and then environment variables, when you look top down, It will first look in environment variables for an API key. If it can find it, you get it. Otherwise, it'll look in app settings.json. Otherwise, it will look at shared settings.json. And that is how it works. So the order of how you added those providers matter. So who here uses configuration in .NET? Everyone, basically. Who here has created in their current code base a configuration builder? Okay, still more hands than I expected, but still not everyone, right? And that begs the question, then how does that work? If I've not created a configuration builder, how can I use configuration? That's, of course, the defaults set up for you by the .NET system. So you can either call host, create default builder, and then do kind of things with that, or you can do web application create builder, and this sets up for you a default configuration setup. Again, this is something that I don't see a lot of developers, or most developers, understanding, and therefore doing weird things in their configuration system. So first you get app settings.json. That is the lowest priority item. Then there's app settings.environment.json. Notice that I didn't say app settings.development.json, which we're probably all familiar with, because this environment bit is set with the .NET environment or ASP.NET Core environment variable. So by default in your launch settings, this is set to development, and that's why you have an app settings.development.json. But you can also create app settings.test, app settings.staging, app settings.production.json, and per environment then override the defaults that you set in that file. Really, really useful. Then you have user secrets, and this is basically the place where you should be storing your secrets during local development. At least that's the default way provided by .NET. And this is only available when that environment variable is set to development. These are not actually secrets. We're going to talk more about that later for why that might be important to you. And then there's environment variables, which I think a lot of us are probably then using with containers to override and set the values during deployment. And finally, you have command line arguments. Anyone here using command line arguments configuration in their code? I've never seen it used before. Maybe to override like ASP.NET Core URLs when I'm running locally, but never seen it used. But this is how you can see it. If you would provide key important value, your code would always use important value because it's the last provider in the list with the highest priority. It's the first one where it looks. Okay. So now we have a basic understanding of the configuration system in .NET and the kind of the defaults. Yeah, there needs to, someone with a microphone needs to walk around, or I can also just repeat the question. Sure.
I'm just curious, coming from more of a front-end background and recently into back-end, and there I was more used to .env files. And I was curious, like as I tried it, first time I tried my C# development, I was like, how the fuck do I put this inside? Because it did not want to pick it up. So I was just curious, is it because .NET is built that way and it needs special implementation to pick up that? Or I was just not able to configure it properly?
Yeah, you're trying to use .env files to configure secrets in .NET.
.env files.
Yeah, that's what I'm trying to say. Yeah, thank you. Yes, so what you are trying to do is not by default supported in .NET, but because you can add your own configuration providers, there's a NuGet package that you can download, like an npm package for .NET called .env or something like that, and that adds this exact feature. So then it will add a new provider, and it will read that .env file and set the secrets that way. I do think that this is not a good idea, and we'll talk more about that later. I think that the .env is a bad idea, but you know, I got to keep you a little bit on your toes. Any more questions so far? Okay, let's continue. So the options pattern, we now understand the basics, and now there's also some downsides, which I want to demonstrate. With .NET's structure, we can do something cool, right? We don't have to treat these things as key value pairs, but we could actually treat them as things that belong together, which we could maybe want to do in a class, right? So we could have external API settings, and then create a class called external API settings, and pass that around in our code base. This way, you can create extension methods, you can have compile safety, you can do really cool things, and treat configuration as code, which makes it easier to use. So how would you do that based on the primitives that we just talked about? Is this readable, or should I zoom in a little bit? It's okay? Yeah? Fantastic. So we have an external API client. This has an iConfiguration instance, and maybe when we call external API, we say configuration, get the section or get required section, external API settings, and then call .get, which means it will now go through your configuration system, it'll look for external API settings, and then it'll try to match the property names to the names in your configuration system and bind them into the class. You can also create an existing instance and call .bind, and it'll do the same thing. And now you can have the configuration settings in .NET, in C#, and do something with them. To me, there's three main problems with this approach. Does anyone want to share some thoughts? Okay. So, to me, problem number one is that we can access all irrelevant configuration. So we have an external API client that has access to the entire configuration system, right? Meaning that if this class would want to get the logging settings, if it would want to get connection strings to a database, it could do so. This is not a security risk. This is all read-only in a running application. But it is giving the class too much data. You know, we're always trying to write the code with as little stuff as it needs. We're not entering a service provider into every class. We're only injecting what the class needs. But that is not what we're doing here. Here we're just telling it, have the configuration system and figure it out, which is kind of annoying for maintenance and testing, etc. The class also needs knowledge of your configuration structure, right? We're now saying get the external API settings. Over time, you might change how your configuration system, what it looks like. You might change it to external API options or whatever. Fact is, now at runtime, you're going to get an exception that it cannot find this configuration because you've changed it in app-settings.json, and you didn't realize that you also need to update external API client, because that doesn't make sense. We're now tightly coupling the structure of your configuration to business logic. And that is going to be kind of annoying to maintain and refactor and going to cause runtime exceptions, which we don't want. And finally, you also have magic strings in your code base, which we also kind of don't want to have or minimize. So we're going to throw this away, and we're going to opt into the options pattern. Now, the options pattern is a better way to work with your configuration, where it truly tries to decouple your configuration system from your code in a proper way without the downsides that we just mentioned. So you get things like encapsulation, dependency injection, validation, named options, reload on change support, post-configuration, and a whole lot more. And we're going to talk about a few of the most important ones. So how do you use options? So instead of doing what we did before, in your program CS, in your startup CS, you can say services, configure my external API settings, and pass in your configuration system. What this will do is once you inject options with that type, external API settings, into a class, it is going to only once go into your configuration system, look for external API settings, look for those properties, bind them to that class, and then inject them for you. This basically sounds the same thing, this sounds like the same thing we did before, where we called bind. But the thing is that iOptions is not directly tied to your configuration system. If we would want to change the way that our configuration system looks like, we can change that in your startup or in your program CS, and this code would remain the same. It does not know that it's coming from your configuration system, so you don't have these problems. Let's see, this is basically what I'm trying to say. Yeah, the next thing is that this class now only has access to the external API settings, right? We're no longer injecting iConfiguration, so any changes that we make to that structure will not break this class. And to me, I find it very nice to see that, hey, this class is using some sort of configuration and it's using exactly that. I find that very nice to see in a class constructor, because then I know exactly what to expect when I'm going to read the code, instead of an iConfiguration and I need to really analyze everything. The next thing is validation. Now, who here believes that validating user input is a bad idea? Who dares? No one dares. Okay, I've never found someone who actually dares. Still looking for that one person. Okay, who here validates their configuration system? 10 people. That's not many. And why I believe this is so important, I could even say that maybe validating configuration is as important as validating your user input. Let me give you a bit of an extreme example. Let's say that you had to add a feature where you can press a button and delete the database for test environment purposes. Great, so your connection string on your test environment is now pointing to the test database, and your colleague updates it to prod. And you test the button, and your prod database is gone. Very extreme example. But this means that our test environment technically launched with an invalid configuration. This is not what we want. We don't want the test environment to connect to a production database. A little bit less dramatic. What if I could pass in a timeout in milliseconds, and I pass in -3? That's going to cause weird behavior in your system. At least going to probably cause an exception. At runtime again, and then you need to inspect it and get a bug fix, and the customer is going to complain. I prefer that my system cannot launch if the system is not in a valid state. So if the configuration is incomplete, if it is not meeting the validation rules, I don't want the application to start. I would just want it to crash and just refuse to do any service because it can only cause bad behavior. That's the concept, and that's what I believe is very important. In .NET, you can use this in several ways, and the easiest way to get started is to use these attributes, right? You're probably familiar with ASP.NET Core, you're probably familiar with these attributes. So we can say an API URL is required, so it has to be a non-empty string. The same thing with an API key, and the timeout in milliseconds needs to be between 1 and 100,000, for example, right? And what you can do, this is the only few lines of code you need to start adding this to your system, is you can say services add options instead of configure. This returns an options builder. You can say bind configuration, so you don't have to pass in the configuration system. It will just do that using DI. And then it will do validate data annotations. And finally, it will do validate on start. And validate on start is very important. In fact, it is so important that I believe in .NET 7, they added a method called add options with validate on start, because developers, I think, don't realize that that is important. What I said before is that the options pattern only initializes the first time it's injected, right? So if you are in a code path where the external API settings is only needed maybe half an hour after application start, and then it calls validate data annotation, only then will it crash. I prefer validate on start, meaning when the host is started, resolve all of my configuration, validate it, and crash the entire system, crash the application, exit once it is in an invalid state. So I truly recommend that you start doing this in your code. It's only a few lines. You can use these attributes. You can also call validate, which is a method here, which allows you to write your own validation logic, etc. One more thing. Currently, we've all seen bind configuration, right? It's kind of loose coupling now. If you want, you can change how your configuration system is initialized and the options are passed to your business logic without having to change your business logic. If you want to be more dramatic, you can also call methods here and do, for example, async calls to another service and get values from there. This doesn't need to be coupled to your configuration system. It can be any code you want, and you can set the values in what way you want. So this is how we truly decoupled configuration from business logic. And then you might have wondered about that options interface. Why do we need that? Well, first of all, we need that kind of for this magic around validate data annotations and all that kind of stuff. And also because they designed it this way where you can have 3 interfaces. So we have iOptions, we have iOptions snapshot, and iOptions monitor. Is there anyone here in production that uses snapshot or monitor? Yeah, like 4 people, exactly. So options is a singleton, which is fine. But that means that, for example, if your configuration system changes during runtime, which you can do with app settings.json and user secrets and all that kind of stuff, then it won't pick those changes up because it's performant and it's cached. Yeah, one question there. I'm going to have to ask you because the person with the mic is running towards you.
Sorry, is that the same with the Asia app configuration? So if you have the refresh that you enable, and then if you use the iOptions only, it wouldn't actually refresh?
Yeah, you're just wasting CPU cycles at that point.
Thank you.
Exactly. Great question. Really good. We're going to talk about that later as well, I think, a little bit. If we have time left over, I'll dive directly into that, but we're going to cover a bit of Azure App Configuration as well. But exactly, if you inject iOptions T, it will never change again. So that's why we have iOptions Snapshot as well. This is scoped, so it's read every scope. A scope in .NET is an abstract definition, in most cases meaning, for example, an HTTP request. So when an HTTP request comes in, it creates a scope, and during this entire lifetime of the HTTP request, if you, for example, resolve the connection string during the beginning, it points to test, and if you change it during the request and resolve it again, it will still resolve the test. It is stayed the same for the entire lifetime of the scope. You do need to keep performance in mind, because if you're, for example, connecting to 5 external cloud configuration providers, and that takes 1 second, that means that all your requests will now take 1 second longer. So keep performance in mind here. Finally, you have options monitor, for example, in a background service, where you're just running something in a loop. There's not really the concept of a scope. So options monitor allows you to grab the current value. So you can call .current value, and it'll always immediately connect to your configuration providers, reload the ones it can reload, and grabs the newest values for you. Like I said, this is very useful with background services. So you can use a mix of these in your code. So then you have the question of having an interface in general. I was looking online for some opinions on this, and a lot of people don't like the interface. Is anyone here with a strong opinion on iOptions around the type you're injecting? Is anyone like, yeah, I don't really like that? Yeah? Yeah, see, like a couple people? Exactly. Because a lot of arguments I see is that, well, it's just iOptions, 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 and then I need to call .value everywhere, and it's just kind of boilerplatey. They don't like it, they don't think it looks very, very clean, right? So it's just not very pretty. Can we fix this? Yes. Should you? I'm going to leave that one a little bit up to you. We're going to talk about it. There is an alternative to this. So if you don't like having iOptions everywhere, you just want to inject external API settings directly, you could do services at singleton, resolve the options, call .value on it, and then inject that result into your dependency injection container. Meaning that you can now go from injecting external API client and injecting all of these options with fizzbuzz and then calling .value, you can just inject these classes directly. It's a preference thing. Personally, I still believe in having iOptions. It's maybe because I'm trained to it. When I look at the code, like if I look at the first example, I know that HTTP client is a thing, and iOptions is just going to be some sort of configuration. And in my mind, that makes sense. I can see them as 2 different things. In the example on the right, of course, these are examples with fizzbuzz and fizzbuzz, but it could still be difficult for you to understand, is this like a thing and a dependency we're calling, or is this configuration? This is a me thing, and it's also a you thing. There's not a strong case to make for why one is better than the other. Of course, there's some things about if you use this with iOptions snapshot or monitor, you're going to lose the current value thing again. You're going to lose the reload thing. But just be aware that there's 2 options, both are valid. So, thought that was worth mentioning. And then I want to deal with development. Any questions so far about options and the things we talked about? No? Oh, yeah.
Yeah, it's more when we register the options.
Yeah.
I saw that you did name of and then the type.
Yeah.
And I personally find it kind of redundant to have settings inside of my settings, like to describe the name, like name settings everywhere.
Right.
And other times I might want to have something dynamic where I configure multiple services with the same prefix, and then I might have like a name afterwards and whatnot. I personally used anywhere from a constant that has to be on every single settings.
Yeah, that's what I do too.
Yes.
Yeah.
Like
a section name, it's what
exactly,
I call it.
that's the same I use. But for something like that's dynamic, I've done like an interface with an abstract
Right.
static name and a method that will resolve this thing. I was just thinking, like, do you have any other ways to do maybe like a dynamic name to avoid having magic strings?
Right. Okay, so you're saying, just to check if I understand what you're saying, right, is you're saying we're doing, we're still connecting this here, and you have all of these strings anywhere. Or in my case, I have a property in this class called section name. So you don't have to do this kind of stuff everywhere. If you change the class name, you're not breaking your system. And you're saying, yeah, but we still have all of these strings anywhere. Can we do this in a dynamic way?
Yes, so let's say I've got something called my service settings,
Right.
And the section name is just my service, but I might want to register any number of these services.
Right.
So now I have to add my service underscore or colon.
Yeah, I get what
service
you
one.
mean.
Yeah.
What you can do is I think you can do this just in .NET. I was going to say you have to use reflection, but I don't think you do. So in .NET you have the configuration, and then you can get the children, and then you can just do a for each on the children and say for each object in configuration or just the parent objects, if the name ends with your thing settings, then call this code and then bind configuration with that configuration object that you're now looking at, because you're looking at a section, and that you can also pass in here.
Right.
So I think you can do exactly that, and then everything that's service in the end is configured that way. I think you could probably do something like that.
Right.
I think so.
Yep. Thanks.
Okay. Any more questions? Do you need to do the block for each option type? Yes and no. So at least one line, you can at least remove 2 lines. So you can say add options with validate on start, external API settings, because that's what they added. So then it's 2 lines. Yeah, you could still create an extension method and make it a little bit easier for yourself, like services add options and add my own options, and then yeah. But you do need to call it for that. But you could maybe look into doing something dynamic, and then it resolves everything for you. Yeah. Okay.
So I'm sometimes confused about the structure of, for example, app settings.json or the structure of options in general. So the Kestrel settings are on the root level, and there's a section for logging.
Yeah.
And then, so how do you do it for your own app? So you might still have a lot of options, like different kind of options.
Yeah.
Do you create a root section for your app, and then like different sections in this root section?
Right. That's
how
a
do you
great
do
question.
it?
Well, there's lots of options. So what do? I've never really run into this problem. I'm not saying that it isn't a problem, but you're saying, for example, in your app settings.json, you have logging, allowed host, connection strings, and then you have all of your own stuff. You could say that you could maybe turn it into like server features, app settings, and then do it that way. I've never done that. I don't really see the problem, but you could do that if you wanted to. We're going to talk a little bit about my preferred configuration approach in a little bit, in a few slides. That doesn't cover that, but I guess you could solve it that way. Yeah. Okay. Let's move on. So we talked about all of this, and now we're going to deal with development. So secrets are things like connection strings, API keys, all of these kind of sneaky things. And prevention of leaking these starts already at the development of your app. We should hopefully all know that we should not just store these in your repo and push them. Some people do that, and then they're like, oh no, I'll just revert the commit and push it, and then it's gone. No, it's in your commit history. Removing commits is terribly difficult. Don't put them in your repo. And I'm going to touch a little bit upon the fact of using .n files as well, because you're still putting them in your repo. So don't put them in your repo. But if you're not putting them in your repo, where do you then put them? You're not going to put them in app settings.json. Well, with .NET, you're going to put them in user secrets by default. You can also put them in .env, and you can also do a lot of other creative things. I have seen putting them in launch settings.json and then Git ignoring the launch settings, so everyone has to configure that file, which is really annoying. You shouldn't put them there. you should use user secrets. Someone adding an app settings.local.json, overriding the current environment, messing with lots of other .NET tooling, and then adding the app settings.local to git ignore. No, use user secrets. It's just working against what .NET wants you to do. The goal is they're secrets. You don't want to have them in the repo. So yeah, let's talk about this instead. So it is so built into .NET that it's just built into the .NET CLI. So you can say .NET user secrets init, and then you can set secrets, right? So you can say connection strings database is data source, admin password is hunter2, stuff like that. You can also do this in Visual Studio, in Writer, etc. I'm going to show that in the demo. What this does is this creates a JSON file, just like app settings.json, but it puts this in a different location than you might expect. On Windows, it'll store this file in AppData, Microsoft, user secrets, secrets ID, which is stored in your CS proj, and then secrets.json. And on Mac and Linux, it's stored in .microsoft in your home directory, user secrets. You get the idea. This is great, because now, if your source code gets leaked, the secrets are not a part of it. And I believe that this is better than a .env file, because if your local repo gets leaked, your .env file is in there. Your env file is still a part of your repo, it's just git ignored. So you're just one accidentally change from your git ignore away, or I don't know, someone having access to your code from leaking it. This is actually storing it outside of where the code is. This is better. It's not secret though. Microsoft and naming and Copilot and etc., we all know it's not secret. The problem here is that secrets, these are just stored in plain text somewhere else on your computer. So if you're working, for example, for like a government or for like a really big, secure company, they might say, well, we don't even want you to have any secrets on your machine at all. Because if you have malware or some weird stuff running on your machine, they could still open this file and leak your secrets anyway. We're going to talk a little bit about the key vault and local usage on how we can tackle that. But be aware that they're kind of secret, not really. But it is the default way that I would recommend you to start moving your secrets away from storing them in the repo and move them into this provider instead. And if you already have secrets in your repo, you first need to revert them. So invalidate the existing secrets, create new ones, store those instead. Don't just move them, because they're still considered leaked in Git. Then there's the good setup for local development. So configuration system in .NET is very flexible. It's really cool. You can do loads of things. I've seen loads of things. I've just talked a little bit to you guys, and we do things in different ways, which is completely fine. But that means that if you were to come to my project, or if I were to go to your project, I would not really understand where a certain value is coming from. If there's like 5 providers and I want to debug something, I'm like, what is happening here? Why is it not the value I'm expecting? I do this. So my app settings.json is a template of all configuration that I kind of create myself. So I have app connection string database from key vault, admin password from key vault, welcome text, well, could just be hello world. App settings.development.json is the same thing. So here the connection string database is from user secrets, hopefully telling my teammate, don't put it in here, because then we're going to fight about my connection string being different than yours and getting a million commits, changing them all the time. Put them in the user secrets. Or, hey, where were they stored again? User secrets. Same thing with the admin password. And welcome text, it's still app settings.json. It's still overriding your app settings.json. So this could be hello developer, right? And finally, in your user secrets, you can then store the actual values. A lot of the times I also use from environment variables when you're using containers, stuff like that. Now, one thing I would say is I then create a custom required attribute that validates that the values don't start and end with like those little smaller than, bigger than. Because now we are providing values for them, so they're always having a value, so the required attribute doesn't do anything. It's a little hacky, I guess, to have a custom attribute for this. But if I can go to any of my older projects or any project in my company, I can understand the configuration system, because that is the bad thing about .NET's configuration system. It's too flexible, maybe. I really like this. I really recommend something like this. So you can go onto any project, understand where you need to look, where you need to obtain a value, where you need to change the value. Okay. Okay. So let's now push to production. The problem here is that user secrets is great, but it's only enabled during development. And in your production environment, you're running .NET environment being production, or you're not setting it at all. The default is then also production. So that doesn't work. So what do? Let's talk about some common approaches. So who is using something like this? I'm not going to shame you if you are. There's something where you have an app settings.json file, and then you put like a placeholder in there. And then you change the placeholder in your CI or in your CD. No one is using this? Okay, that's pretty cool. I see this really often, right? So this is kind of, well, maybe from the olden days or some other languages that do this. And what you now can do is in your pipeline, you can have the secrets, and you can say, if in the pipeline variables there's C string database, then in my CD pipeline or in my CI, I hope CD, you change them. And then your app settings.json will contain the secret. You could say that's not really a bad idea because they're not stored in Git. They're just on my deployed environment. Two things. First of all, again, you're working against what .NET wants you to do. .NET wants you to work with providers and precedence and priority. So it wants you to, for example, use environment variables, which is the next provider. So that will override app settings.json. The second thing is that if you're doing this, and you're doing this on your own server or on CI, and for example, your artifact that you're deploying is deployed on a build server, that means that that build server has your secrets in a zip file somewhere. One of the biggest targets for like finding secrets and hacking companies and figuring out what their secret values are is hacking their build servers, because no one maintains their build servers. It's always Windows XP or Windows 7, stuff like that. So from a security perspective, this is not a really good idea as well. So that's why I want you to try to use environment variables more often. So you can still use these values. You can still store them somewhere. These are still secret, and now they're deployed as an environment variable in your system, and they're not a part of the file system or the build server and stuff like this, and you're doing what .NET wants you to do. Okay, but then is the question, where do you store those secrets, right? I already at the beginning asked everyone here who's using the Key Vault. There's loads of people here using the Key Vault. And so the service is Azure Key Vault, allows you to store secrets, keys, and certificates in Azure. There's also a service for this in AWS, Google Cloud, all that kind of stuff. And the cool thing is that you can use this as a configuration provider in .NET. So you can say config add Azure Key Vault URI. So this is like the URL to the Key Vault, which we have stored in our app settings.json or in an environment variable, and then you connect to it. And now you added a new configuration provider, which is the last provider in the list, which has the highest priority. And so it will, whenever you grab the database connection string, it will grab it from the Key Vault. So this means that you don't even need to struggle with your CI/CD and how your secrets are part of your deployment. You can just grab them at runtime instead, which has upsides and downsides, because what if the Key Vault is down, then your application doesn't run? But it does massively simplify your release and secret strategy. One more thing here is that I recommend that you do this during development too. So in a scenario where you're not allowed to have secrets on your machine if you're working at a big secure company, what do? Well, you can do this. So you can say during development, grab the values from the Key Vault instead, and then the cool thing here is that I can just give my code to my colleague, he runs .NET Run, and his authentication will automatically connect to the Key Vault and grab the values. So there's no more README with like a 6-document page on how to grab the values and prepare your local environment. You just grab them from the cloud instead. If you need a bit more of an advanced thing, you can use Azure App Configuration. So this is it's the first thing that Microsoft has named correctly. It's configuration as a service. So you can store your application config and your feature flags in one place. It also links to the Key Vault. So here you can say config add Azure App Configuration and then connect to that URL. And now it has a new configuration provider. And this does both configuration and secret management. It has features for A/B testing, feature flags, timed windows. It has lots of things. It has reload on change support. So if you want that, that is pretty cool. You can change log settings or feature flags without redeploying or restarting your applications. It is a little bit expensive. I think it is 30 euros per instance per month. I find it expensive if you do that per resource or per service. So at the companies where I used it, I just created one instance for the entire tenants and used service prefixes. Doesn't really matter how you use it. It is personally a bit expensive for what it is. It's a key value store, but it's useful. But there is a problem, right? There is a problem. How do we connect securely to these services? We need some sort of authentication. If we would need a username and password, okay, let's connect to the Key Vault. But where do you store the username and password? Do you store them in app-settings.json? No, because if that is leaked, someone can log into your Key Vault. So Azure has solved this with Azure authentication. Other clouds do this in the same kind of ways. Other clouds, for example, AWS also has configuration providers for their secret management. But in .NET, you can use the Microsoft Identity or Azure Identity package, which will allow you to have a look, and the system will look in your Visual Studio or VS Code or Azure CLI or Azure PowerShell, find your existing Microsoft token, and use that to grab the values from the Key Vault or app configuration, etc. So if your account has been configured with RBAC in Azure to have access to the Key Vault, you can just .NET run and everything will work. It works this way. So it will first take a look in your environment variables for like a service principal. Then it'll look for workload identity. Then it'll look for managed identity. And during development, it'll look for Visual Studio, Azure CLI, Rider, loads of other places where those secrets could be stored. And that is a really nice way to do this. So you should be using this Azure Identity and default Azure credentials and all those kind of things. For non-local scenarios, when you're pushing to production, you want to use managed identities, right? So in Azure, a managed identity is basically an account that Azure manages for you. So you can tell an app service, you are now app service. And then you can talk to your Key Vault and say, I want app service to have list rights to the secrets. And then whenever the app service calls the Key Vault, it will ask Azure, hey, do I have permission? Yes, get a token, send that token to the Key Vault, and it will authenticate. So you don't need to manage any API keys or secrets yourself. It's all managed by Azure, which is really, really nice. All right, the main thing here is there's no need to manage secrets when there's no secrets to manage. A little example of that, for example, if you have an app service or a container app and you want to talk to Azure SQL, you can have a connection string, and you can see there's no username or password here. The only thing is Active Directory default. And this will then loop through all that list of authentication providers and authenticate for you. Who is using this in production, the default Azure credential? Okay, a few people. So I want to tell you that you should stop doing that. A bit dramatic. But the default Azure credential goes through this list. If you use a default Azure credential with Azure App Configuration, your launch time of your application locally increases with 30 seconds. That is not a joke. That is not an exaggeration. That is true. The reason is because it goes from front to end. So it's first going to check your system on your local system if you have an environment variable for a service principal. Of course you don't. So why are you checking that? It is also going to check all of these and going to do calls to Azure, and it's dramatically slow. I prefer then to use a default Azure credential and then explicitly disable these. So you can say exclude environment, exclude this, exclude that. So you can still loop through all of the development authentication methods without the slowness. Okay, around 6 minutes left. Let's do a quick demo. Yeah. Okay. So I have a little application here where I want to showcase a few of the secret management things that we talked about. So this application is an ASP.NET Core application, and what we're going to do is when the application starts, we're going to check if we're running in development. If not, okay, then we're going to add the Key Vault. I prefer having it all the time, but for this demo, I just only did it locally. I don't have key vault. In the cloud, I do have key vault. So it's going to say, grab the key vault URI and use a default Azure credential. Then I get the connection string, add AEF core with a database, and I have 2 endpoints, a list of pizzas, which gets a list of pizzas from the database, and an endpoint you should always add to all of your production apps, /connection string, which returns your database connection string. It's a really good idea. My app settings.json looks like this, right? We have logging, connection string, the database. Hey, you should go to the key vault for this. The key vault URI is set to my key vault URI, and then you have app settings.development.json, which doesn't have a key vault URI because it's set in app settings, and the connection string to the database is stored in user secrets. What you can do is if you go right-click on a CS proj, and I don't have a mouse, that's a bit annoying, you can click on Manage User Secrets. You can also do this in Writer, or you can do this via the CLI or whatever, and if you do that, it'll open this file. And here you can see data source dot. This is my local SQL server running. And if I zoom in on where this is coming from, you can see that this is coming from app data. Right? So this is stored outside of my repo. So if I run this and I take a look, what is my connection string? You can see that this is connecting to data source dot. So it's local. And the list of pizzas is as follows. Salami, Hawaii, margarita. Right? This is local. Now, I did the thing that you should always do to deploy to production, which is right-click deploy in Visual Studio. And this is now running in the cloud. And we can do the same thing here. So I can get the connection string. And normally, you should never, ever do this, right? Because, well, you shouldn't have an endpoint with your connection string deployed. But you can see here that there's no login. The only thing is authentication, Active Directory default. And this is working because of managed identities. So in my web app in Azure, I have enabled system managed identity. So Azure creates a managed identity that belongs to this resource. If you delete the resource, you delete the identity. Then in the key vault, I have added a system assigned managed identity to access with RBAC. And I told it this resource is allowed to read the secrets. So my app service is allowed to read the secrets and the database connection string. And then in SQL, I had to run a bit of code, which is as follows. There you go. You have to say create user, and then do the identity name from external provider, give it some SQL roles, and now my app service is talking to a key vault that is returning a database connection string, which is talking to a database without any passwords. So there's nothing to leak. And this is what you should, if you're doing Azure native stuff, you should be using managed identities everywhere. Okay, let me go back to this. Yeah, we have 2 minutes left, which are perfectly on time. Let's go to the conclusion and some final questions, and then stroopwafels. So, number 1, understand configuration provider precedence, because the last provider wins. Prefer the options pattern over iConfiguration. Set up configuration validation at startup. Use user secrets during development. Never store secrets in source control. I was being a bit dramatic about the .env thing, but I still believe they should still not be in the same place where the gitignore lives. Use Key Vault and managed identities for Azure. Like every cloud has its own version of this, which you can also use with .NET. Consider app configuration if you need advanced configuration management. And set up policies around secret management, including rotation and leak prevention and detection. This is not something I talked about. I just want to talk about it for like 30 seconds. If you're using like GitHub or Azure DevOps, there's this advanced security, GitHub Advanced Security, and lots of other services like GitGuardian, which will allow you to set up that when you do push a commit to Git, it will reject it. It will reject your push. And you also want to set up services and alerts for when there is a leak. You can, for example, subscribe to services like Have I Been Pwned and those kind of websites that will automatically invalidate your secrets if they're leaked. This is not a code thing. This is a culture and a policy thing that you need to set up in your company, in your team. Okay. With that, I want to thank you very much for attending. We still have, I think, around a minute for questions, and I'll still be here for a few hours afterwards, so just feel free to also talk to me afterwards. Don't forget 3 things. Grab a stroopwafel. They're here. I'll put it here right now. There's also some at the end, some at the back, some Dutch cookies. Grab some stickers on the way out. And yeah, please leave a review with the cards when you leave. And thank you very much for being here. Great. Do we still have some time for questions? Are there any questions? Yeah, there's a question here at the front. He's running.
Yeah, hi.
Hi.
Thanks for a great talk. You did the data validation part, and then you also said there was the options monitor
Right.
thing. So how does that work? Will the options get validated every time you say options.current, or like if we change configurations on runtime?
That's a great question. I guess? That is a really good question. I have to figure that out. I mean, I think so. When you call .value, it would get validated. I think it should. Yeah, I think it would. That would be a thing. Yeah, that's something I'd have to check out. Thank you for the question, though. Yeah, great. I think so. Any more questions? No? All right. I'll let you guys go. Enjoy the rest of your day, and yeah. See you later.